Hello, my name is Kıvanç Tok and I'm from Turkey. I finished 6th grade and will move on to 7th grade this year. I'm 11. I'm currently speaking in the Aspendos Ancient Theatre.
As you can see.
I'll talk about how we can use math to make art through a program called Desmos. It's a website which makes graphs, first of all, but with those graphs you can make art. Somebody even made Bad Apple in Desmos. The first art, which is a little arguable, we're going to make our normal map. So let me just quickly scale this graph and then define a function or surface to define the normal map, to find the normal map of. And that's going to be... That's still too wide, so I'm just going to multiply that by 10. And I realized I made a mistake, plus y squared. And then divide that by 10 to get this surface. Actually divide that by 4 or 5. Yeah, 5 looks good. So to take the normal map of a surface, you need to first find its tangent, which is going to be f of xy equals d over dx, f of xy, and then let's just disable this to get it out of our way, and then this. Oh, I forgot to rename this. And then we're going to have a point P at the coordinates AB, then f of AB. And then we're going to have two vectors. Vector 1 will be the vector from P to P plus 1, 0 fx of AB. And vector 2 will be the vector from P to P plus 0, 1 fy. Fy AB. There you go. And then the normal vector, which I'm going to represent with again, is v1 cross v2. And this is called the cross product. It just lets us find a vector perpendicular to these two vectors. And then we're going to normalize it, so divide it by how long this vector, divide the vector by how long it is, so that we get a vector with length 1. By length I mean magnitude, of course. And we're going to plot the normal vector at 0.3, negative 0.1. As you can see, the surface seems to be pointing that direction at that point. And also, let's just change this to a better location to see the vectors themselves. Let's rescale the graph. And one. As you can see, we have two vectors like this, and we have the normal vector, which is where the surface is seemingly pointing to. And so now what we're going to do is change these up, and also make these p naught x, p naught y, because we're going to see y later. P naught x, p naught y. And then we're going to say, and we're going to take these into parentheses and set a to positive 1, positive 0.8, so on to 1, which as you can see gets us all numbers from negative 1 to 1, with an interval of 1/5. And then for a0 equals a, b0 equals b, which will get us a grid of points and a really messy image as well. Let's just disable these points real quick. Sorry, disable the normal vectors. As you can see, these are our points, and then disable the points and enable the normal vectors. And these are all normal vectors, which are quite messy. So in a sense, I'm going to visualize them divided by 5. And as you can see, they do really seem to point the way that these normal vectors are pointing. Anyway, so now we need to color these points, and for that I'm going to make a new list of points called P0, which is just P on the XY plane, so they all lie flat. And what we're going to color them according to are, you guessed it, the normal vectors. Specifically, we're going to multiply them by 255, or multiply this value by 255, 1/2. This expression is for if the vector started from the origin and it takes its endpoint. So I forgot something, and that's the fact that I need to say RGB in front of it. You might be like, well, it's currently not showing any colors, and that's because we need to repeat this process 2 more times for the y and z axes respectively. And now we have a list of colors. Here are those colors at the end, and we can color P0 of those colors to get our nearly finished normal map. We still have one thing to do, and that's to get these all in a square pattern. And the segments that I do this in will be split up, because it takes a kind of long time. So, but it will still only be split up. I won't. And that is a normal map. This normal map, it does look beautiful, I know, but it has other uses than looking beautiful. And its use is in game development, where you want to have high quality but high speed too, so it'll be smooth, unlike this graph. Oh, not unlike this graph, because it can lag out a lot. You want it to be high quality but also smooth, so you decide to reduce the number of vertices, basically the number of corners, so you basically simplify surfaces, but you want to keep detail, so you instead use normal maps to add in the detail. That's the use of normal maps. Here are a few more examples I'd like to show. First being the musical dots. Oh, damn it. Nah, there you go. Here are all of its formulae, which I wrote. And this is how I make the noise. So let's just scroll through if anybody wants to see. Then there's this, which I made a video of, which you're gonna see. So it's basically graphs complex functions, like that. For example, this is the inverse of the complex number, which turns straight lines into circular arcs. And then there's this floral patterns. These two just make these strands, as you can see. And this P factor is like how many petals the flower has, but 3 against 3 looks funny. 4 against 3 doesn't look that funny, it actually looks nice. And then you can change A to get simple, double, triple, quadruple, quintuple, hextuple. I couldn't decide if I should use Latin or Greek there. I was using Latin, so sextuple. And then, yes. And then there's the stopwatch, which is very complicated, let's say. So these are like the settings to speed up and slow down. And then there are the colors, like this. Yes. I have 1, 2, 3, 4, 5, 6, 7, 8 special colors for this. Functions. I have a function to make these hands, and a function to progress the time. And then I have a bunch of variables determining, like, it's this going around, like the points, these dots. And then we have the time variables, which are the variables for the time. As you can see, if I run the stopwatch, the seconds represented by S goes up. It's actually in milliseconds, don't ask why, I just left it like this. This was like, it says 10 minutes ago, and that's because I made some changes, but it was like a couple years ago. This is a couple years old. And then there are the visual settings, visuals settings, nice naming there, old me, which sort of just changes like the positioning of stuff. G, oh, I see. But I. Okay, so non-clickable visuals. It's this watch parts, and then there are clickable visuals, which are these, which are this, and this. Also, there's this funny thing. It goes to negative 1 minute and 59, negative 1 hours and 59 minutes if you go backwards. Yeah. And then there are the settings variables, and it's basically the speed up, which goes from 1x to 1000x. So here's just regular speed, here's 10x, here's 100x, and here's 1000x. And that's the demos. The 4 horsemen of demos. Oops. Well, see you.